Hi, welcome back to the breadboard. Been a little while since I've done a video, sorry about that. Anyway, you might be wondering why I've got remote controlled car and aircraft stuff in front of me. Well, today is the 1st of June 2019, and in Canada, the law for remotely piloted aircraft, that includes airplanes, helicopters, lighter-than-air vehicles, quadcopters, anything that basically flies, including hobby things where you're standing on the ground with a remote control, old school like this, or one of the new 5 gigahertz, 2.4 gigahertz, 900 megs, whatever. The law changes. And so I thought I would take the opportunity today to kick off a new topic on my channel where I'm going to go through how to build some various remote controlled vehicles and things. Now you wonder why, on my channel, breadboard, electronics, it's industrial control and things, why I'm picking to do this. Well, in the good old days, and I'm talking 25 plus years ago, things like this, they ran on a 27 megahertz transmitter, and anything you did on the remote, it was a PWM, was directly sent to the motor or steering servo. There was no real logic or intelligence in between, aside from a transmitter to get the signal from one to the other. It might as well just been a solid piece of wire as far as any interaction is concerned. These new machines, quadcopters, aircraft, and everything else, including cars with the new controllers, they're working on completely different bands, so 2.5 gigahertz, but they also have a huge amount of intelligence, logic and control circuitry, algorithms between the control on your transmitter and the actual work end of your model. So in this case of the car, it would be the right now a DC motor. In the case of a pocket drone aircraft or something, it would be the motor that's driving propellers to push it through the air, or the servos that would drive ailerons or something like that. And if we take something like a drone, not this one specifically, this is a low-cost one. We'll talk about some of the law changes in a minute. This just has one main microcontroller in it that does everything. It's very simple, very low cost, very light. Comes with the batteries. I think this one is under $100 Canadian, and that's including batteries, remote control, everything. This one, there is probably at least, once we put a radio in it, 7 microcontrollers running this thing. They implement proportional control loops and all sorts of things where whatever you do on the controller end doesn't necessarily have a direct bearing on what happens on the motors. So for instance, on a quadcopter, an aircraft and things, you've got rudder, you've got throttle, etc. Running multiple PID loops in here so that when you turn or move a control on your remote, it's saying, I want to roll my vehicle at X number of degrees per second, or I want to accelerate at a certain rate, I want to tip the vehicle forward. In the case of a quadcopter, that would obviously make it move forward. It's not directly, I want to change the speed of the motor. The algorithms figure out what to do with the motor in order to get the vehicle to do what your control has said. So there's a lot that is relatable to industrial control loops, whether it be a CNC machine, a 3D printer, actually they're all CNC machines, but 3D printing, CNC wood lathe cutting machines, laser cutters, sewing machines even, so quadcopters, remote control cars. There's so many different things where you've got input from a user, i.e. a remote control, and you have motors or something else that you may be controlling. It could be a heating system which has got motors in, blowing fans and things like that. And in between there's a lot of logic and programming and control that goes in to make all that stuff happen. So I wanted to do a series based on using things like quadcopters, remote control cars, in order to explain a lot of those operations. So we're going to go through how the transmitter works, how it reads the input from the user, puts it into something that can be transmitted over the air, how a flight controller works. This is just the same as a PLC in a factory that might be controlling motors and heaters and various other things. And then how the ESC works, which is a BLDC motor, or to put it another way, a three-phase motor that could be anything from a 3D printer, in this case a quadcopter, a laser cutter, a regular laser printer even, that has stepper motors and things like that, and or BLDC motors where you want some kind of reaction to your stimulus to make something happen. And I figured this would be an excellent platform to go through all of that and explain how it all works. I know I started a program, a series a couple of years ago with power supply DC load, and I'm going to be continuing that as well. Some of that's going to overlap in with this too, but I'm also going to spin this one off because I've done a lot of industrial control, and a few of you rightly so have been saying, hey, too much review of industrial products, let's get back to some electronics, see how things work and things like that. So guess what? It's coming up to the summer. The laws have just changed in Canada, and they're changing all over the world. The last 6 months since this alleged Heathrow incident and Gatwick incident in England with alleged drone sightings, and everything happened after that, within 6 months the laws all over the world have been changing and constraining what we can do as far as a aviation hobby is concerned. It hasn't affected ground vehicles yet, but it certainly has affected things that can fly. And so I'm going to show you how to build things. We're going to go over some of the laws that have changed and how you can work legally within them to still enjoy the hobby and things like that. But I want to also give a lot of other people an understanding of how this stuff actually works. So this one, we're going to start talking about the drones to start with, and I'm going to take you through a couple that I have here. These have been provided to me by Banggood. Thank you very much, Banggood, who sent me these. A lot of the other parts, like the transmitter, batteries, cameras, video receivers, and some controllers I have in this box here, I've bought all of these myself. So not everything is fully sponsored, but everything here you can buy from Banggood, or whatever your friendly vendor may be. But I'm going to be pointing links to Banggood through affiliate link and things. I'll also provide other ones for the things that I can't get from Banggood, and we're going to go through how to set up a quadcopter. I've never flown a quadcopter in my life, so this is brand new for me. I do understand the principles of how it works. I used to race, and this is one of my this is probably 25-year-old original Kinwald edition Team Losi XXCR racer. I bought this when it first came out, and when it was a world champion car, and used to race it in England. I've got a few other vehicles offshot over the side here too that I used to race. So we're going to look at these as well, but we're going to focus on the quadcopters first. But this side of it is brand new to me, so I'm not a skilled pilot, so you're going to learn right along with me and see the mistakes I make. Hopefully nothing that breaks too many things. One thing to know about quadcopters, and I've seen this mentioned a few times, is if you don't expect to break something in a quadcopter and you're new to it, don't get into it, because you will break something. If you're not trying to learn how to fly it properly and things like that, it is inevitable that things will get broken. So it's a good thing to learn how they work and how you can replace things, repair things, and even build them from scratch. So without further ado, let's talk about some of the laws that have changed here in Canada right now. As of today, or as of previously of today, you could fly a quadcopter up to about 1 kilogram pretty much anywhere you like, as long as it's safe, you're not too near people, you're not causing a nuisance. There were restrictions where you could not fly too close to airports and things like that. I'm not going to go into the specifics of how far away, because people from all over the world will watch my videos and it'll be different for everybody. And there wasn't really an age restriction, so you could buy a little model airplane or helicopter or quadcopter for an 8-year-old, fly it in your backyard, and it would not be an issue. As of today, that changes. You can't do that anymore. If you're under the age of 14, you cannot fly one of these without adult supervision. And not only that, that adult supervision has to have passed the test. So it's a technical test that you do online at the government website. You pay $10 to do it, and you have to know about all sorts of things with aviation. Some which I find absolutely ludicrous when it relates to the hobby level of flying vehicles like quadcopters, planes, helicopters, but definitely would relate if you've got one of these big $10,000, $20,000 commercial quadcopters that you use for surveying and all sorts of things like that, or rescue. So age-wise, you have to be over 14. If you're not over 14, you have to have a certified pilot adult supervision while you're doing this. This is for any quadcopter over the weight of 250 grams and under, I think, 25 kilograms. So it's quite a wide range, but that low level is quite low. If you want to be an advanced pilot, you have to be over the age of 16 and do an additional test. Both of these, theoretically, this one I know is well under that. This one, I haven't weighed it yet with a battery in it. And by the way, the weight includes the battery. I believe is supposed to be able to be flown without having to have certification or register. And that brings me to the next point. As soon as your drone goes over 250 grams, and it could be 1 gram over, you have to register the drone with the government website, pay $5 to register it, and different countries, different prices, and different terms. Like England, I think it's £16 for registering, but I think that might allow you to register more than one drone under the same registration. And once you've registered it, you're going to get a number of things that you have to put on the drone. And if you get caught flying your drone outside and you don't have that number on it and it's over 250 grams, you can get fined an awful lot of money. So not worth it. Flying under 250 grams, there's no licensing. You're still got to be sensible. You still can't fly within 3 nautical miles, which I think is about 5.6 kilometers of any airports or aerodromes and things like that. And there may be other airspace restrictions. For instance, where I live, my house happens to sit just within a Class D airspace, which technically means I shouldn't be able to fly anything over 250 grams, even in my own backyard. And by the way, being in your backyard doesn't make a damn bit of difference. If you're in a restricted airspace, you're in a restricted airspace, period. If you don't have a license, you don't have a license, period. Okay? I have not seen anything in the legislations, and any of the videos I've watched from XJet and other places that have talked about the laws that say that the law doesn't count if you're in your own backyard. So be warned, be careful. If you fly under 250, you're probably okay. If you fly over 250, you're just asking for potential trouble and fines. So enough said about all of that. That's just an intro as to why I'm doing this today. I'm going to now just move the remote control car stuff out of the way for the moment. We're going to have a look at some of these. I'll get a weigh scale out and show you. I'm going to hopefully get a lot more remote control cars and planes over time to both review, and I'm going to try and specialize in some that are under 250 grams because that's the one that pretty much anybody can still fly without worry of being crapped on by the law or whatever else. Okay, so here is the first drone. This is the one that was sent to me a while ago to have a look at, and this is the Eachine E58 quadcopter. It's a little pocket drone, folds up as you can see. This is it folded up. Comes with 2 batteries, comes with some prop guards. Props are already mounted. It has some little standoff feet on the one end of the quadcopter, and then because of the way that the blades are in, the other ones are there's not one on the other side, so it keeps it level. These ones I 3D printed. I did take this apart and take it out and have a quick attempt at seeing how well it'll fly, and I guess I didn't have one of these in properly and I lost it. So I found a model on Thingiverse, printed it, and it fits great. And I like the fact that now I can see which is the front and rear easier as well when I'm flying. So that's the quadcopter itself. Comes with a manual, and it comes with a dedicated transmitter. So you've got 2 joysticks, one for throttle. This one's for throttle and pitch, I think, and then you've got roll and yaw or whatever. Getting used to the term still. And then you've got some takeoff and landing type button. There's some extra buttons on the back as well, where you can have it in different speed modes, and you can control with, you know, a little automated loop the loop and stuff like that. We will take these out later and give them a fly outside once I've gone through some of the electronics in them. This one, I've got some pictures and I'll start putting them up in a moment of the inside. There's really not much to talk about. There's a board that controls the radio receiver, driving the 4 little DC motors that are pushed into these plastic housings here. So to get it ready for flight, you just pull out the arms, top ones, bottom ones, and that's basically it, ready for flight. You take a battery. As I said, it comes with 2. These have got little micro USB ports on them, so you can just plug them into a standard USB charger. They're a single cell, what does it say? 3.7 volts, 500 milliampere hour. So little batteries. They'll give you, probably quite a few minutes of flight time. Don't know yet. And all they do is they just slip right into a hole at the back of the drone, right in here. Put them up the right way, I guess. You just slide it in, and that's it loaded up. You do have, in this case, a 2 megapixel camera on the front here, down here. Still got the cover on. Let's just take that little label off so we get some better quality pictures. So you can fly at FPV if you want. I don't think it uses FPV frequencies because it'll come up on, so I guess it's not really FPV as such, but it will transmit the video to a cell phone or something like that, where you could potentially record it. But I think, I'm not sure, let me just have a look, see if I can see. No, I can't see any slots where you would plug in an SD card. But the very fact that it's sending it to the a cell phone means you could record it if you want to. So that's the machine, and to turn it on, you just got the button on the top. You press it, and the lights come on and flash. And then now it's blinking because it's not bound itself to a transmitter. The transmitter here, I think, takes a, I'm not sure what size battery. It comes with a USB lead, by the way, and a screwdriver and spare props, because you're going to break some of it at some point. So let's just take the screwdriver here. See what, let's just turn that off for a second. I don't want it doing sillies when we're messing with a transmitter. I can't remember what, I think this is just a single 9-volt battery that goes in here, but I could be wrong. Nope, goes 3 AA batteries to run this. The transmitter battery should last quite a while. They don't necessarily need to be rechargeable in this case. I think for the bigger, more advanced transmitters, and we'll look at one of those in a minute, you do need to, I think, have rechargeables in if you want to be able to use them without changing a battery every flight. Anyway, so you turn this on with a slider switch, it'll beep at you. So now when I turn this on, it should, I believe, bind with the transmitter. So turn on the quadcopter, turn on the power to the transmitter, it'll beep, push the stick forward and then back, and then the lights come on steady. Now you're ready to fly. Now I'm indoors with a very low ceiling, so maybe I'll just hold it and push the stick for throttle. No, you got to use a button to say go, and that will lift up. I'm not holding it. Okay, so you push the up button and it started it to lift off. You push the down button, it kills the So, as you can see, a little bit of work to do to figure out how to use these controls properly, and we'll do it outside, because I'm sure stopping it from moving up and down and things like that is probably messing up the accelerometers and everything else inside, which is why it's going into a flashy light mode again. Because this does have gyro, let me just see if I can see it written in here, or on the, built into this little model, You've got the high definition camera, Wi-Fi connectivity, so you can control this from a cell phone if you want. 2.4 gigahertz. It's got a built-in gyroscope. It's got accelerometers and things. Does not have GPS. Neither of these two have GPS. Obviously the lights are built in and things like that. So it knows its altitude. It knows the way it's facing. It knows whether it's moving or not and things like that. So if I constrain it like I was doing here, holding it on the ground, on the bench, then it's not going to like that much. It's expecting when I hit start that it's going to probably elevate to a meter or two up in the air. So what does it say in here about that when you start it? Yeah, so this is the throttle. So it would, if you, without any forward momentum, you would just either increase or decrease the propeller speed to make it raise up or go down. So you got one key takeoff, one key landing. This product is determined by the barometer in a variety of environmental, temperature and other factors. So that's really the quick review of that. Now, how much does this one weigh? There we go, that's zeroed. So let me just let that zero. Let's sit the quadcopter on it. Now the battery is installed, so this is the flight weight of this quadcopter. Now I know you can't see that, but it's reading 96.2 grams, so well under our 250 gram limit. Okay, so this is great for younger people. I mean, yes, it will wrap your fingers, but it's going to be nothing worse than a paper cut or something if the propellers did hit you. You do get propeller guards. Oh, they're not on there yet. Let's stick the propeller guards on and see what it weighs with that. All right, that's zeroed. Wow, exactly 100 grams with the prop guards on. So that's not bad at all. So perfectly easily within the legal limits of what you can fly in Canada. All right, let's put this one aside and we'll pull out the next one. I'll make a separate video for the flight testing. Okay, this time around we have the HGLRC, I know the model's written on here somewhere, HGLRC XJB 145. This is much more of a hobbyist, rather more than a toy, certainly not a professional, but hobbyist small racing quadcopter. This again is from Banggood sent this to me, and this one is what a lot of more people associate with like a racing slash freestyle quadcopter. You can see well packed in foam. This one comes pre-assembled with the exception of a few things. A little bit of a manual. Let's see what is in the packet here. Certainly comes very well packed. So we've got a few stickers. So I guess you can stick them on things. Quality QA pass certificate. Strap, I presume, to hold the battery in. It's running beta flight, so you get a diagram that explains, whoop, get the camera right, there we go, what everything is going on. We'll have a closer look at that in a minute. Basically, we've got two boards currently on here. One is the flight controller, and one is the VTX, was what they call VTX for the video. So we will have a look at that. So let's pull out the quadcopter. Blades are not installed yet, just a bit of foam. So this is how the quadcopter comes. You can see when I actually compare it to this one, it's actually smaller. Difference is this is made out of plastic, very lightweight. Little batteries, and you got to have a dedicated battery that's going to fit in the battery compartment. Whereas this one, you actually strap a battery onto the bottom of this. You've got, right now, you can see that there's 3 boards in here. One of them is going to be the ESC. One of them is going to be what they call a VTX, which is the video transmitter, TX for transmitter. And one of them is going to be the flight controller. So the flight controller takes the signal, they leave the wires hanging out here for you to do this, from the receiver and passes it down. Now, we'll go into in separate videos about how the receiver and the transmitter talk all sorts of different languages. But at the end of the day, when it comes out of the receiver, it has to be in a mode, so it's either pulse width modulation, pulse position modulation, or some kind of protocol. For instance, they call it S-Bus, which is like a smart bus, or things like that. We'll go through protocols and stuff as we go through the video series too. We have BLDC motors, not DC motors, so these are brushless motors mounted on the quadcopter. These ones are Flame, what are they, HF1407, 3600 kV. So the 1407 means that they're 14 millimeters wide and 7 millimeters tall. And this is not the overall thickness, this is more the rotor and things, not right to the top of them or anything like that. The propellers use a nut to hold them on, and it comes with propellers, and these propellers don't fold up. These are fixed blades, whereas on here, these propellers, you can see when they're not flying, when they're not being powered, they just flop around. So these are a little safer for catching your fingers on and things like that. These ones are rigid, potentially more likely to break if you catch your fingers on them or if you run it into a tree or something. Looking on the quadcopter, we've got a buzzer at the back here with two lights on there, two LEDs. We've got the power connector for a battery here. And on the front of the quadcopter, we have a camera built in, a little cap on it. So a little and this is, you can either just send this to a recorder if you're flying it close to you. This could be just sending video to a screen for other people to see what you're seeing. It could be going to goggles if you were wearing goggles and things. Now, just to touch on a quick point with things like this, when these are flying, if you look at this, look at the angle of this camera. If people get concerned about privacy and stuff like that when you're flying a quadcopter near them, the fact that everybody's running around with a smartphone with cameras built in is that people don't tend to care about. The minute you start flying a quadcopter, it's, oh, you're trying to spy on me. But most times people are not. These things make a lot of noise when they're flying. But look at the angle; it's pointing up in the air. So if that's hovering, it's not recording something down here. It's recording the sky. When these things are flying, they usually fly at an angle like this. And when they're flying at an angle like that, they're not going to be hovering. They're going to be flying forward pretty darn quick. So this, and again, making a noise. So you're not really going to be having much chance to spy on people. So if you're not a flyer and you think people are trying to spy on you, just consider for a moment the setup of most quadcopters. They're not designed for spying. They're designed for racing and doing stunts and things like that. And people are just having a good time, minding their own business. So anyway, this is the basic quadcopter. What it doesn't have in it is a receiver. Okay, so I decided, as you can see here, on using the FR Sky receiver, not the big XR8 one, but the smaller XSR. So it is up to 16 channels through the S-Bus. What I've done is I've soldered it directly from these wires. I cut the connector off the end and I've soldered it directly to the underside of this connector here, because the plug, I would have to pull the plug out and rewire it and everything else. So one end had to be cut. I figured I might as well cut the plug off the end of the leads coming off of the flight control board, because then I can change the receivers around quite easily and not have to worry about it. And they're soldered at the other end of that anyway. So it will all work out just fine for me. I've just sort of bound these up fairly neatly at the end here just for the sake of testing. I might take that down a little bit just so it doesn't get pulled into the props. Wouldn't want to do that. Anyway, I haven't put the propellers on yet because I want to make sure things are turning in the correct direction, etc. So I need to set up and bind it to a transmitter and just verify that things are going to work properly. So if you put the propellers on the wrong way round, it's going to push downwards instead of pushing up and stuff like that. So, and I've also got to bind it to a receiver, to a transmitter, and I don't want to do that with the props connected either, because if you've got something weird set up in a transmitter, it could just go flying off into oblivion if you're not careful. Now what you can also see here is I've used a couple of bits of plastic pipe cable tied to one of the stanchions to run the two antennas up. This way it keeps them nice and stiff. They're not going to get pulled down into the props, and they're off in two different angles, so that if the machine is, you know, twisting around like this or like this, then it's going to switch from one to the other for a strong signal. The weight of this now, with the transmitter, with the receiver, the propellers, the nuts, the battery attached, it comes to only 214.5 grams. So we're still easily well within our limit of 250 grams. So there's no need to register this. There's no need for certification training. You can fly it pretty much in any country completely legally, providing you follow the basic rules about keeping away from airports and people and stuff like that. All right. You can still get into trouble if you are reckless when you're flying these. Next thing then is I need to get my transmitter out. Now I did buy one. I've got a couple coming from Banggood. They just haven't got here yet. They may be here in another couple of weeks' time. I have the Taranis X9 Lite on its way to me, and I also have a more economical FlySky IX6, I think it is, as well, which should be able to go on here. It doesn't use S-Bus, it uses I-Bus, but from what I can tell, this controller will handle I-Bus on one of the other leads as well. So we're going to looking at some different receivers and transmitters in a separate video. For now, I just wanted to get this basically up and ready to run, and then we'll do a separate video on flight testing and things. I just want to make sure it's all set up properly and everything else. So some of the features that I haven't quite mentioned yet, I've mentioned the motors and the controllers, and we went through detail on what the chips are. We've got the receiver now on the top of the stack. We've got the two diversity receiver antennas on here. We've got the 5 gigahertz, 0.8 gigahertz transmitter for the video, which is going to come from this video camera here. We've got our battery. We've gone through the ESCs and everything else. What's left is the frame. The frame is made out of, at least the base of it, it's 3mm thick carbon fiber. It's got little pointy bits in various areas on here that are designed to protect the motors. If you catch it, like on this angle, it'll hit the carbon fiber before it hits the motor. Now obviously the prop is sticking out. These things are about 3 inches, so they will obviously be out beyond the edge of this. But, you know, props are cheap. These motors, you know, they're a lot more expensive than a prop. So you want to try and protect them a little bit without adding too much weight and everything. So next thing is I'm going to get out. What I did get was I got one of these jumper. They were very economical price for its features. Was a jumper XT12, I think the model is. Anyway, jumper T12. Sorry, not XT12, just jumper T12. So it's a little transmitter. The nice thing is it can handle a gazillion different receivers. It emulates FreeSky, FlySky, Futaba, well, a huge list. I will do a separate video on the transmitter. For now, I just want to get it set up. I've never actually even powered this transmitter up yet. All I've done is put batteries in it. I've never had a receiver to do anything with. So let me just move this out of the way a little bit, and I'll show you the transmitter. So this is the jumper T12. Again, you can get this from Banggood. It comes with a multi-protocol module in the back. So all of the basic functionality of this transmitter is handled in a microcontroller inside the transmitter. So you've got your standard joysticks, trim adjustments. You've got switches for different modes all over the place. You've got adjustment knobs on the sides. As I said, we'll go through this. USB for charging, and also like a buddy box, so you can have a training mode transmitter going through your transmitter. So if you're trying to teach somebody, or if you've got a young kid that you're supervising, you could have the master control of a model They could be flying, but with restricted controls perhaps. And you could take over at any time on your transmitter if you wanted to. On the back, we have this multi-protocol module which plugs into this expansion bay. Now for this transmitter, you have to have this module in for anything to work. It does have, or it does look like it was built to have an internal transmitter, but the T12 does not have an internal transmitter. If I just pull this module out, so there's a set of pins in here. I don't know if you can see that in here. Turn it around for the light. Down here that the module connects to. So there's transmit, receive pins, power, and probably a bus signal as well. Inside this module is a number of different transmitters that are compatible, like I said, with FreeSky, FlySky, Futaba, and Spectrum, I think, as well as a whole bunch of other ones. They're all running on the 2.4 gigahertz band. And the controller in here is just going to switch between the different transmitter chips so that it will be compatible. Lots of firmware in there and things like that. So we're just going to pop this one back in. I'm going to need to set it up for FrSky, which when you're using it in the jumper transmitter, you can do that directly from the control panel for setting it up. Going to have to figure out how to do that, of course. We will, as I said, we'll go through it in a different video. Batteries. This transmitter comes with a battery pack for 4 AA batteries. So that would give it 1, 2, 3, 4, 5, 6 volts of operation. You get a little kit of bits for adjusting the gimbals, make it left and right handed, etc., and adjusting the tension, return to 0. Shoulder strap, charging lead, and what I have and what I've put inside here is the other battery module, which allows you to run a pair of standard 18650 LiPos. So that's all I've done with it so far. As I said, I'm not going to do a full review or walkthrough of this right now. What I've got to do is I have to set it up to use FreeSky, and then I have to bind it to the receiver here so that I can control this model. Once I've done that, I can check that the motors are turning correctly and things. I'm going to leave this set up, this transmitter set up in its default mode as far as its tuning and curves and everything else is concerned, just to see what happens with it. And I'm not going to tune or do anything with the default setup of the quadcopter either. So this is basically what it would fly like out of the box if you spent 200 Canadian buying the model, you know, $30 for a battery or a bit less. The T12 radio is I think under $100 or around 100 Canadian. So 2, 3, you're talking about 300 for this particular setup here. 200 for the model, 30 odd for that, so 230 receiver, another 20, 250. So probably about $350 it would cost you to get to this stage here. I've got 2 batteries. I don't have a battery charger yet. I have one on its way. So you would have to get a battery charger, which could cost you anything from $40 or $50 up. You know, you can spend hundreds of dollars on a really good one. You can buy one that will just simply work well enough for what you're doing for like $40 or $50. So when I get mine, I will show you it and we'll go through it. For now, I'm just charging this off of a precision bench power supply and setting up the parameters for the battery. So they're not getting balance charged at this point in time, but they should be fine because they're new. And I guess the next step is for me to just bind it up. So I'm not going to do that on camera because I've got a lot of futzing around and figuring out how to do that. I will show you how to do it in a separate video though. And we'll see if this is set up. You've got to put the props on the correct motors for the orientation of the props because they go in counter-rotating in order to prevent spin of the model. If you get them on the wrong place, it's going to go down instead of up and things like that. So Anyway, I'll just stop it here a second and go do that.